this video is on inverse proportion, and I'm doing this video on the assumption that you've either watched my previous video on direct proportion or that I've shown you this in class. So this is trying to use as little algebra as possible. So you may have seen the version where it's equations and you're creating equations, substituting things in. But of course, if you're not that good at algebra, you don't understand it that well, then this is just a much more logical way of doing it. So we've had a look at direct proportion, and that meant that when one thing increases, the other thing increases at the same rate. So if one thing doubled, then the other thing would have to double. Now, inverse just means the opposite. And what it means is the opposite in this sense is if one thing increases, then the other thing will actually decrease at the same rate. So if one thing doubled, the other thing would half. And the most obvious real life situation for this is if you've got an amount of workers and an amount of hours that it would take that amount of workers to complete a job. If we had 10 workers working on a job, and that job would take them 12 hours, then if we doubled the amount of workers we had on this job, so say we had 20, then it'd take half the amount of time. Because there's twice as many people, we'd halve that, and it'd only take 6 hours. We could also say if we halved the amount of workers, so if we had 5 workers, then it'd take longer, and because there's half as many, it would take twice as long to complete this. So if 5 workers were working on this job, it'd take 24 hours to complete it. Now, in the other one, we tried to find a link between the two rows, and for direct proportion, we divide the bottom row by the top row, and it'll give us our value of k. So we want to find something that's going to be constant across all of these, and see if you can spot that just by looking at the numbers. If you haven't spotted it, then if we do 10 times by 12, we get 120. If we do 20 times by 6, we also get 120. And if we do 5 times by 24, then yeah, we get 120. So that is our constant. Whatever you times, or whatever the two numbers are, when you times them together, they have to make 120. So for this situation, the value of k, our constant of proportionality, equals 120. So we can use this, because if we know that we have 40 workers working on a job, we know that these two numbers times together need to make 120. So 120 divided by 40 gives us 3 hours. If we had 40 workers on this job, it would take 3 hours. So we could also say, how many workers would it take or how many workers were on the job if it took 60 hours? Well, exactly the same situation. The two numbers need to multiply together to make 120. So if you do 120 divided by 60, it tells you that there were 2 workers on this job. So that's our constant of proportionality, and that's the link that you need to find in these questions. So the question could look like this. The first bit is the information. Y is inversely proportional to x. When x is 4, y is 10. And that's the bit that we can use to find the link. So just like in the last video, whichever is on the right, so it said y is inversely proportional to x, this one on the right we put at the top. It's less important in inversely proportional because when you're timesing things together, it doesn't really matter which order you times them in. But if we just keep it consistent with the other one, so x and y, when x is 4, y is 10. So when x is 4, y is 10. And remember that link between them is when you times them together. So 4 times by 10 equals 40. That tells us that whatever those numbers are, they need to times together to make 40. That's our value of k, 40. So in part A, it says, what is y when x equals 20? Well, we can just fill that in. X is 20. We need something that we times by 20 to get 40. So if we say 40 divided by 20 equals 2, so y must be 2. So the answer to part A, y is 2 when x is 20. So for the second part of the question, it says, what is x when y equals 5? Well, y is 5, so fill that in that part of the table. So we need something that times us by 5 to make 40. So every pair has to make 40. Well, what do we times by 40 to make 5? If you can't spot it straight away, it's 40 divided by 5, which is 8. So x must be 8 in that case. So we've answered both the questions there. When x is 20, y must be 2, and when y is 5, x must be 8. Now in the previous video we looked at one where it had a square as well. But it's a bit easier when it's inverse because we don't need to do any dividing or anything to find So instead of putting x in there, we just put x squared and y. And drawn up our table, we can use the information. When x is 5, y is 4. So we put 4 as our y, but we can't put that value of x straight there because we need to square it first. So when x is 5, x squared will be 25. And we find our value of k by timesing the two numbers together. So 4 times by 25 equals 100. So every pair has to times together to make 100 because the value of k is 100. So what is y when x is 5? So we know that x is 5, so x squared is going to be 25. Don't really need to answer much more of the question because we've already got 25 there, so we know it needs to be 4. But what is x when y is 25? So y is 25. We can fill that into our y row. The two things need to times together to make 100. So something times by 25 is 100. 100 divided by 25 equals 4. So x squared equals 4. But we don't want x squared, we want x. So we need to square root that. X squared equals 4. So x must be the square root of 4, which is 2. So when y is 25, x is actually 2. So that's the answer to that second part of the question.